So now we're looking at division. Note we are now dividing two complex numbers in polar form. It's going to feel very familiar, except now instead of multiplying the moduli, we're going to divide them. Instead of adding the arguments, we're going to subtract them. The overall process, though, is going to feel like a whole lot of deja vu. So taking care of those moduli first, we're going to have 2 over 4. We'll go ahead and reduce that later. And then we still have our cosine and our I sine. But again, instead of adding those arguments together, now we're subtracting. So we're going to have pi over 2 minus pi over 3. So cleaning this up a bit, 2 over 4, that's the same as 1/2. And now we have to play around with fractions just a little bit. Pi over 2 minus pi over 3, we do not have common denominators yet, so we can get them multiplying the left fraction by the denominator of the right, multiply the right fraction by the denominator of the left. That'll give us 3 pi over 6 minus 2 pi over 6. So again, just getting common denominators there. 3 pi over 6 minus 2 pi over 6 leaves us with 1 pi over 6. So we'll have cosine of 1 pi over 6. And even though it looks like there's 3 things we need to do here, keep in mind these arguments are the same. So then we'll also get I sine, forgot my I sine of pi over 6. So if they had asked for us polar form, we would be done. This is the polar form of that quotient. Go ahead and move this plus, make it a little cleaner. So again, if they had asked us for the polar form, we would be done right here. Unfortunately, they did not ask us to just get this into polar form. They want full-on rectangular form. This again, cosine of pi over 6, I sine of pi over 6. I recommend pulling out a handy-dandy unit circle, because again, cosine of pi over 6, sine of pi over 6, these are values that you can just look up. Alternatively, some calculators can do that for you. If you still have the geometry calculator, it can take care of things like cosine of pi over 6 for you. Cosine of pi over 6 is root 3 over 2. And sine of pi over 6 is 1/2. Keep in mind there are still things that we need to take care of here. So there's that 1/2 hanging around outside. And we also have an I. So we need to distribute that 1/2. And then just clean everything up. Note that 1 times anything is just the anything. So the 1 times root 3 is just a root 3. In the denominator there, we have 2 times 2, which is 4. And then jumping over to the imaginary part, same thing, 1 times 1, that's just going to be 1. So I'm going to leave the I in the numerator there, and 2 times 2 is 4. And that would be our rectangular form. So again, we have 2 different ways to write the exact same complex number, one in rectangular form, one in polar form. Make sure you're paying attention to instructions. It will tell you which form the final answer ought to be in. We'll go ahead and look at one more division example, and then we'll start getting into things like powers and radicals. We'll start having a great time. So looking at one more division example, similar to last time, we want to divide the moduli, the numbers that I have here in green. So we'll have a 6 over root 2. Don't freak out, we'll clean that up in just a minute. And then we also want to add those arguments. So setting up my cosine and my I sine here. Our arguments in this case are going to be 7 pi over 4, and I think I just said add. Subtract, we want to subtract the arguments. 7 pi over 4 minus pi over 2. Keep in mind we're doing that for both cosine and sine. So there's a little bit of cleanup that we have to do both in the angles And with that modulus 6 divided by root 2, we don't want that root 2 in the denominator, so cleaning that up just a little bit, we can multiply by root 2 over root 2. So now we'll have a 6 root 2 over 2. Of course, we can clean that up as well. 6 over 2 reduces to 3. So our new modulus is 3 root 2. And then jumping inside the parentheses here. Once again, we don't have common denominators. Maybe you're noticing a theme here. 7 pi over 4 minus pi over 2. We can rewrite that pi over 2 as 2 pi over 4. And so now I'm taking 7 pieces of pie, getting rid of 2 pieces of pie. That leaves me with 5 pieces of pie. So I get 5 pi over 4. I will get the same angle as an argument to sine. 5 pi over 4. So again, if they were asking us for this quotient in polar form, we would be done. That is the polar form of these two complex numbers divided. However, they did not ask us for polar form. They did ask us for rectangular form. So we need to do a little bit of work here. 5 pi over 4, that is an angle on your unit circle. 4 pi over 4, that's the same as 180 degrees, so we're going 45 more. So we're talking about the third quadrant here, where both cosine and sine are negative. So we're going to have a negative root 2 over 2 for both cosine and sine. So putting that with everything else that we need in order to get our rectangular form, keep in mind we do have a distributive property coming into play. So we have a 3 root 2 times that negative root 2 over 2. There's still an I and a 3 root 2 times the negative root 2 over 2 there. So this one's a bit uglier, but not something we can't handle. Square root of 2 times square root of 2 is just 2. So note we'll have a 2 in the numerator and a 2 in the denominator. Those will cancel. So root 2 times root 2 over 2, that's just 1. So we wind up with a negative 3. Same thing will happen here on the right. Root 2 times root 2 is 2. 2 over 2, those cancel, that's just 1. We don't want to lose that negative, and we really don't want to lose the I. Keep in mind there's a real part and an imaginary part. So we'll have negative 3 minus 3i, and that's our rectangular form. So that's it for division. We've looked at a couple multiplication examples, a couple division examples. We also want to start playing around with powers, as well as radicals. So those will be the next two big topics. Powers are going to feel a whole lot like multiplication, just surprise, surprise, with an exponent. Radicals are going to be a bit more challenging. So if you're having questions on where we're at so far, maybe pop by after school. Let me know if there's anything you need, and I'll see you soon.